Emmanuel, the next two presentations are to do with the Olympics in Paris and spectrum demand and planning. So I gather you've had a busy summer. Just click through when you're ready.
Thank you. So, thank you, Martin. Good afternoon to everyone. And thanks to Shaw for inviting me for this this presentation. So Olympics, tremendous work for many people, of course, and exciting collective experience during the games. I'm quite sure that John Dundas will speak some about the actions during the events. Here with this presentation, I will more refer to the investigations upfront with respect to spectrum planning and how to make available the necessary amount of spectrum and about also the rules associated with the spectrum planning. Spectrum management plan. So it's basically it's a reference document that should list the frequency bands available for the use of the various media applications and others to support the Olympics. There were quite some sharp timelines to make it happen, and to go through this, we had to go through an interactive process with the incumbent services, with the representatives from Paris 2024 on the demand side. It was all the more difficult also as we had to where we had to put pressure on the incumbents within the administration, so including on the military to get access to some spectrum, to get the commitment on some sufficient amount of spectrum, but also on their own they had to be ready and to calculate their needs, which could evolve with time during the process of preparation of the Olympics. Spectrum bands, the availability depends on the locations, depending on the radar sites, earth stations, receiving stations, and so on. And we had to deal with more than 40 venues to accommodate the Olympics. In terms of timelines, it was essential to be able to deliver by June 2022, which means 2 years before the games, the spectrum plan. It was provided to, it was coordinated, worked together with the Olympic organization, and then the so-called spectrum management plan that was formally published in March 2023. You have a list of bands which is provided here for illustration. With the next 2 slides, I'd like to give some hints about the many studies that were to be performed as part of the spectrum planning process to be able to qualify the effective availability of frequency bands and also to identify the necessary coordination constraints. Because when the time comes to make the necessary frequency assignments, you need to be able to know with which kind of stations and stakeholders you need to coordinate. For instance, you had a number of cases for which we had to support the work with studies with radars. So the first one which is mentioned was for audio application using the 2040, 2060 megahertz bands, and there were some measurements made to support this with real equipment. I mentioned the band 1300, 1350 megahertz were used by various type of radars, part of the L-band radars. It's quite interesting here to draw your attention to the also exceptional demand for aerial means. As you may guess, when it comes to ground to air or air to ground links, coexistence with incumbent services may be more tricky. And if you take this example, the 50 megahertz of spectrum. Of these 50 megahertz, only 10 megahertz could be identified as being reliable for kind of uplink towards the air wings, those relay planes that fly at an altitude of 8 kilometers. And for sure, if you want the transmission towards this relay plane to be reliable, you need to have investigated beforehand the bands. 2.7, 2.9 gigahertz bands we used in sharing with ground radar stations, the S-band, I believe. It was used only by ground video links. One had to avoid channels that were, of course, co-channel near the sites, or in some cases adjacent channels. It all depends also about the distance between the venue and the radars. Coexistence with mobile network operators, referring to the downlink bands where the base station transmits. It's a specific case to be looked at. There was a baseline guidance not to locate receiver of wireless camera in proximity to base station, but at the end of the day there were not so great, not real difficulties. We had difficulties with the 3.5 gigahertz band. Within France, the lower parts of the 3.4 to 3.8 gigahertz band is authorized for fixed broadband access. It's not 5G, but based on the measurement, we could understand that it was not so much reliable for vis-a-vis the base station transmission, partly because the band is not filtered within the standard. The L bands, or the 14, 27, 15, 18 megahertz band is quite famous within CPTs. It's harmonized for the downlink, single downlink band for its MFCN. It's for mobile fixed, or the mobile networks. We had anticipated that it could be a good candidate for those fixed wings at 8 kilometers above ground, taking into account also cross-border aspects, because in reality you need to first, within France, it was made clear that the band should not be authorized, assigned to mobile operators before the Olympic Games. So the ARCEP, the telecom regulator, may now initiate some process. But as a matter of fact, in some neighbor countries like Belgium, Germany, UK, and Italy, there had been some frequency assignments to mobile operators before. So originally, it was seen as a good candidate for ground-to-air links, but finally, because of this situation, including in neighboring country, it was selected for air-to-ground links from helicopters. Another slide on this coordination constraints and effective availability. I mentioned already the case of receiving Earth stations. So there is a need to define some sort of exclusion or coordination zones around some Earth station, and based on this kind of information, you can compute some channels can be made available to the video links. But I like also, still on the aerial means, I like to draw your attention to this the sharing that was put in place with in MSS bands, mobile satellite service bands. The baseline rule that was followed to make it happen is to support the use of ground to air or air to ground in the reverse direction to the direction of the satellite uplink down. you have some illustration with the figures. I will this figure. If you take the example of number one, basically you are in uplink MSS bands, and with this kind of configuration, transmission air to ground from an helicopter is quite interesting, because you can expect some proper antenna discrimination towards the space station, and obviously there's no risk of causing interference to the MSS terminal, because it transmits in this band. I don't go through all the details. Maybe below you have the interesting specific case of MSS 2 GHz, which is partly, especially the Inmarsat band, is used supporting some aeronautical satellite services. In this case, we had to make some choice and to decide that, for instance, the downlink band should not be made available, because under so that's sketch number 4. Under this kind of configuration, there would be some risk of causing an interference from the PMSE equipment towards the receiver on board an aircraft. So I'm insisting on this because when you start with this spectrum planning work, there is quite some pressure to meet the demand, and you don't know exactly what the demand the real demand will be. So you need to maximize the opportunities in terms of frequency bands. At the end of the day, they may not all be used, but it gives some necessary flexibility to find proper solutions. Frequency assignments. I think in total, I think more than 22,000 licenses have been delivered. So by license, you have to understand it's one license per equipment, per site, and per event. So if the same equipment will be used on 2 sites, you need two licenses, and also depending of the opening or closing ceremony, games, and depending also whether it's for the Paralympic and Olympic games. Yeah, very briefly on the frequency assignment process, I just want to draw your attention to the fact that yes, of course, there was a spectrum booking portal that was made available early 23 for stakeholders to book frequencies. And with respect to video PMSE, I like to underline that there was, because of the density of venues within Paris, there was a need to define some clusters for proper frequency reuse routes. In other words, below you see Trocadéro, Eiffel Tower, Invalides, and La Concorde venues. So for a given service, you would define the pool of frequencies that are available per cluster. In other words, a given, of course, within one venue, you don't reuse the same frequency, but you had also to take into account other venues in the vicinity. And within the tools that were supporting the frequency assignment work, the conditions of sharing with the incumbent services had to be computed. And lessons learned. I should be quick. So some lessons or facts for your information. The idea that power limitation to 50 milliwatt for audio PMSE would help reducing intermodulation out of 3. The channel bandwidth of 200 kilohertz. The situation where only 50 kilohertz was assigned could cause some tricky issues, because then on site you may discover that finally it's more than that. So maybe safer to assign 200 kilohertz. When you had a major stakeholder asking for a bunch of spectrum for PMSE audio, we would deliver the requested channels to the best possible extent, with a random channel spacing of minimum of 600 kilohertz. That was kind of rule implemented. With respect to the bands, only very few requests in the VHF band. The UHF band overloaded, and for instance, if one stakeholder would ask for too many channels, a push was made towards these kind of stakeholders to use the 700 and 800 duplex gap for use. The 1200 band already mentioned was essentially used by a Japanese company, and the 1300 band, actually it's 1350 to 1400, which is harmonized within CPT. We had no request for this, but at least for us, we still see it as a good candidate, and there is no. We need to encourage maybe both administration to make it available and equipment maker to develop equipment. Video PMSE, typical channel bandwidth of 200 megahertz or 16 megahertz. Broadband of 3 megahertz between channels that was used commonly, in particular for the aerial links. No demands above 750 megahertz, and again, no, actually, at the end of the day, no demand for the 3.4, the lower part of the 3.4 gigahertz band, probably because the fear of the adverse impact from the base station was quite a deterrent for the stakeholders. At the end of the day, no real adjacent band issue. It did work. The other bands, well, 1400 to 4990 megahertz. Only a small portion, only a few channels were made available. It's quite sensitive, but in this kind of bands, they were used for so-called telemetry system. I think what we call telemetry system here are some sort of video return the users, and we like to advocate the 2.7 to 2.9 gigahertz spectrum as a good success, because it did offer a solution for ground-to-ground link, even if we had some interference cases to handle in Marseille, but it did work. Some other, I think the problem of filtering some DECT equipment is quite well known nowadays, and it suffers from the impact of the adjacent base station transmission. There was some coexistence issue with GPS, but it was managed. And last but not least, there were quite significant amount use of license exempt bands, and there was an obligation for the stakeholders to register to get an authorization for this, for any use within the use, but we had to educate also people, because and there was a situation of interference with some referees communication applications. Also, some other channels could be found on the spot. I mentioned already the DECT issue, and there were some UWB application used, but they were not so robust with respect to the active services. The last I will just show, because the slides will be available to you. So again, yeah, we have to be cautious with this figure on the number of licenses, but it provides some information. Obviously, the TV UHF ban was very critical, and then in yellow you have an indication about the bands which are within the recommendation, the CPT recommendation 2510, and some other bands which were used for the occasion. Another slide on the a display of those figures for the video links, number of licenses. I just want to show that so again, you have those bands which are within the CPT recommendation, which are tagged, as you can see. And on the right side of this slide, you can see those bands which were made available for aerial means. So the second column lists the options that were made available, and the last column provides an indication of what was used effectively, at least mostly used. And finally, examples of extracts from studies, even where there were some studies made to support the protection of radio astronomy in Nancy, southwest of Paris. And you have, with respect, the so-called 2.6 gigahertz TDD band was made available for PMSE links, but this band is authorized in France for private LTE networks. So depending on the location of this network, you have to figure out whether the channels could be made available. So this matrix would present the results. And the last part of the annex gives you an indication of the frequency reuse rules that were set for competition venues within in close proximity within Paris. So that I already so you have an illustration of the many sites within Paris, and I mentioned this already. And measurements were made in different kind of situation at 7 gigahertz for instance, and you have to derive some rules from this kind of measurement, and ultimately you deliver some sort of matrix to support the frequency assignment. You have the list, those acronyms are acronyms for venues, and of course when it's in red, for instance between FL and Trocadero, it means you cannot reuse the same channel. So this concludes my presentation. Thank you.